6.4, we have 3 special parallelograms that we're going to talk about, and they're all parallelograms, right? The parallelogram we talked about last week had those special properties. First one having to do with the word parallelogram, meaning the sides, opposite pairs of sides are parallel, because you got the word parallel in there. Not only are they parallel, they're also congruent, okay? Then you go inside the parallelogram to the angles. Opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other, okay? So all of those properties of just regular parallelograms are true about the 3 that we're about to learn about. But there's extra special properties that apply to them as well, okay? So the first of the 3 parallelograms is a rectangle. Rectangle, obviously a parallelogram, right? Both pairs of opposite sides are parallel. All those other properties are true. But the special property we're going to learn about today is that the diagonals, not only do they bisect each other, but the diagonals are also, who wants to guess? What else do you think? If we drew in a diagonal here and a diagonal here, not only do they bisect each other, but what else do you think is true about them? They're congruent. They're also congruent. All right, so we're gonna put a little tick mark on this one and a tick mark on this one. The whole thing is congruent to the other one, okay? Remember last week we put a single and then a double and a double. Okay? So now the difference is they're both congruent to each other and they bisect each other, all right? The second special parallelogram that we're going to talk about is the rhombus. So you'll see the rhombus on the worksheet. It's this first one right here. If you need to trace it, just put it under your paper. Oh, I can't see through mine, but you should be able to see through yours because yours is not this off color, but it looks a little something like that. Okay? It's kind of a particular way, but I find it hard to draw. Basically, it is a parallelogram because opposite sides are parallel. It has all the properties of a regular parallelogram. But then it also has the following properties as well. First one being that the diagonals are perpendicular. So this little symbol right here, it's a upside down capital T, means perpendicular, okay? And the diagonals are going to bisect a pair of opposite angles. And I'm just going to use the angle symbol. That's the angle symbol. Just draw a little angle, put a little S after angles. So all of these special properties have to do with the diagonals. On the rectangle, they're also congruent. On the rhombus, they're not only bisect each other, but they are perpendicular. And they bisect the angles. And then the third special parallelogram is a square. Square, obviously a parallelogram, because opposite sides are parallel, opposite sides are congruent. The diagonals are going to bisect each other. Opposite angles are congruent. Consecutive angles are supplementary. All the good stuff. And so a square is going to have a lot of special properties, right? Because it's going to have double star in that it has all the properties, obviously, of a parallelogram, all the properties of a rectangle, and all the properties of a rhombus. It's got them all. Square is super special. Okay, so you can mark all sides congruent. You can say that the diagonals are congruent. They bisect each other. They bisect the angles. I mean, we could draw a ton of stuff in there. We can put a bunch of tick marks. There's a lot that goes on that square, okay? Because it pretty much has any property you can think of. All right, so these are our 3 special parallelograms for the day. All right, so here's the kind of questions you're going to see. Example number 1. We're going to start with one of our special parallelograms. We'll call this one JKLM. We'll say that JKLM is a rectangle. And I'm going to give you some information about it. JL is going to be 86 inches. Obviously not drawn to scale. So we need to find a couple things. We want to find the length of HM. All right. So here's our rectangle, JKLM. First piece of information is that JL is 86. So you come over to your rectangle and you find JL. JL is inside that rectangle, so it's called a what? Diagonal. So there's our diagonal, JL. I'm going to label it 86 inches. Okay, if they give you any good information like that, label it. Okay. The next thing we want to find is HM. Do you see an H? No. So what do you think H is going to be? The center. So if we draw in another diagonal, we can make that intersection point H. And we want HM. So on this little piece from here to here, I'm going to put a question mark, right? Or you could put an X or highlight it somewhere, some way, like you had a highlighter or something, okay? So HM isn't even on the same diagonal. It's on the other diagonal, right? But if you come back up to the special properties, you remember that in the rectangle, the diagonals are not only bisect each other, but they're also going to be congruent, right? So if JL is 86, what's KM going to be? 86. So the whole thing is 86 inches. I'm going to write that down. KM is also 86 inches, which the property we just learned told us that. So what is HM? It's going to be half of it, right? We're going to take half of 86. We should get 43 inches. Okay. This is super simple, but make sure you label the information that they give you, the information that they want you to find. Okay? It's all about how you're labeling stuff and pointing it out. And then it becomes kind of obvious, right? All right, example number 2. Let's throw some algebra in here. Okay, so for example number 2, we're going to draw the rhombus. And these are so hard to draw, but we'll get it. Okay. That one's pretty good. Not bad for me. That's like as good as I get. Okay. W, X, Y. Oh, that one's a V. V, W, X, Y. Okay. And we're going to say that V, W, X, Y is a rhombus this time. And let me give you some information. So the top of this rhombus, XY, is going to be 3B plus 4. Down at the bottom, BW is going to be 13B minus 9. We're going to dash in some diagonals here. Very straight. Straight as we can. And this angle right here in the middle is going to be 14A plus 20. Okay, because if you go back up to the top, what did we write about a rhombus? Two things about its diagonals, right? The first one was the diagonals are what? Perpendicular. Perpendicular should trigger what? How many degrees in your brain? What? 90. Okay, so this guy right here, we know is probably going to be equal to 90. Okay, and the other information we know about the diagonals is that they bisect a pair of opposite angles. Well, they're not asking anything about opposite angles yet, but maybe we'll get there. Okay, so let's see. Part A, because we've got the sides labeled also, right? So first thing we want to know for part A is find YV. Oh, there was other one. Oh, this angle right, sorry, this angle right here in this corner is 5A minus 5. So yes, there was one other piece. I almost forgot to give that to you. Y. Okay, so here's Y, here's V. We want this side right here, but we know these two sides. But what else do we know about a rhombus? We didn't mark it on here, but just like the square, all four sides are congruent. Okay, so if we know these two sides, can we get side YV? Yes, so let's set this equal to this. So we're going to say that 13B minus 9 equals 3B plus 4. Let me move that up again. Sorry, I keep going up and down. And let's solve for B. So subtract 3B from both sides. Add 9 to both sides. These are opposites, these are opposites. And we combine what's left. 13B minus 3B is 10B. And then on the right, we've got 4 and 9, which is 13. If we divide both sides by 10, we can change it to a decimal. I've got 1.3. Okay. But we need what is the length of that side. So we've got to take this 1.3 and plug it back in. So let's go. YV is equal to, and we can pick either one of these. Which one looks easier, the top one or the bottom one? I think the top one looks easier. So I'm going to go 3 times 1.3, add 4, punch it in my calculator. I got 7.9. And I had centimeters written down, but I didn't have any units. Whatever units it says. Okay, now let's deal with the angle. So I'm going to move this up. You'll see it in just a second if you're still writing. Okay. All right, part B. So part A dealt with the sides, right? Now let's deal with some angles. So for the angles, we want to find the measure of angle X, Y, V. So here's X, Y, V, which